Hey friends, we're back for Module 9, Part 3. We are on page 267, and we're beginning with the section Microevolution and Macroevolution. Let's begin. As we learned in Module number 1, once a hypothesis is formed, it is tested against experimental data. If the data continue to support the hypothesis, it eventually becomes a theory. If it does not, it must be altered or discarded. This is the next step in the scientific method, and it is where Darwin's hypothesis ran into some trouble. After leaving the HMS Beagle, Darwin began experimenting with pigeons. He raised and bred them, trying to see if natural selection could result in new species of pigeon. To investigate further, he talked to other animal breeders. He interviewed those who bred dogs, horses, and pigeons, looking to their experience as a guide to whether or not his hypothesis could be correct. Indeed, he found much evidence that confirmed at least part of his hypothesis. He noted several cases of breeders who, over several generations, succeeded in producing pigeons that were so different from the species with which the breeder started that they could reasonably be classified as a new species of pigeon. The same seemed to be the case with dogs and horses as well. As another piece of evidence for his hypothesis, Darwin compared the domesticated versions of many animals with their wild counterparts. Wild dogs, for example, looked and behaved quite differently from domesticated dogs. In fact, many breeds of domesticated dog cannot reproduce with wild dogs. Thus, by the definition of species as laid out in Module number 1, these domestic dogs would be considered a wholly different species from any species of wild dog. Despite these incredible differences, domestic dogs were, many generations ago, simply wild dogs that men began to train and domesticate. Over generations, however, dog breeders would selectively make those dogs that had what the breeder considered the best traits for domestication. Thus, the wilder dogs were not allowed to reproduce, and the tamer dogs were. This man-made selection, Darwin realized, mimicked natural selection, allowing the small variations that occurred during reproduction to pile up, leading to a new species of dog, the domesticated dog. With these observations, Darwin was able to do two things. First, he established as a valid scientific theory the idea that the natural variations which occur during reproduction could, when guided by natural or man-made selection, take one species and pile up so many changes that the result could be something reasonably classified as another species. In other words, he showed that his explanation for the many species of finches in the Galapagos archipelago was scientifically viable. Second, Darwin was able to destroy forever an idea that had been established for generations before him: the immutability of species. The immutability of species. The idea that each individual species on the planet was specially created by God and could never fundamentally change. In other words, scientists of Darwin's day believed that every creature was created during the time of creation and has existed essentially the same ever since that time. In the case of dogs, for example, Those who held to the idea of the immutability of the species would say that in the Garden of Eden, there were Doberman Pinschers, St. Bernards, Dachshunds, and Chihuahuas. Each of these breeds, each of these breeds of dog continued, essentially unchanged, up to the present. Darwin masterfully showed that this just wasn't true. He showed that all of these breeds of dog came from some original dog ancestor, and the natural variations that occurred in reproduction, guided by natural or man-made selection, resulted in the many different breeds of dog that exist to this day. Although it sounds like Darwin had remarkable success in testing his hypothesis, you need to realize that what Darwin showed to be true was only a small part of his hypothesis of evolution. The idea that one ancestral finch could, over generations, give rise to many different species of finch was revolutionary, but it was not where Darwin's idea stopped. Once he had destroyed the idea of the immutability of the species, he wanted to go much further. He wanted to show that this same process over millions or perhaps billions of years could eventually cause the ancestral finch to give rise to an eagle. This is where Darwin ran into all sorts of trouble when comparing his hypothesis to the data. Although it was rather easy to show that a species of wild dog could, over time, give rise to several breeds of domestic dog, it was quite another to show that a dog could give rise to a radically different species, such as a horse or a cow. In fact, Darwin found some evidence for this idea, but it was inconclusive at best. We will be looking at this data in depth in the next section, but for right now, it is enough to say that there was so much data contradicting this part of his hypothesis that he spent the majority of his book discussing the problems with his hypothesis. In the end, Darwin found ample evidence that starting with a basic life form, a finch, for example, many other specialized species of this life form, many species of finch, can arise as a result of variation guided by natural or man-made selection. However, when it came to showing that a basic life form, once again, a finch, could evolve into a completely different life form, like an eagle, by natural selection, there was precious little evidence for this hypothesis, and plenty of evidence against it. This has led scientists to divide Darwin's theory of evolution into two parts: the theory of microevolution and the hypothesis of macroevolution. Microevolution: the theory that natural selection can, over time, take an organism and transform it into a more specialized species of that organism. Macroevolution: the hypothesis that processes similar to those at work in microevolution can, over eons of time, transform an organism into a completely different kind of organism. The distinction between macroevolution and microevolution cannot be overemphasized. There is so much evidence to support the idea of microevolution that it is a well-documented scientific theory. There is so little evidence for macroevolution and so much evidence against it that it is, at best, an unconfirmed hypothesis. Well, if Darwin could not find much evidence in support of macroevolution and found a lot of evidence against it, how did it become so popular among scientists? There are several answers to that question, but one of the most important ones is that at that time, scientists were rather ignorant about a great many things we take for granted. As a result, Darwin could argue his point rather convincingly. Darwin basically said that since microevolution is so clearly apparent from a scientific point of view, then macroevolution should also be rather obvious. After all, if inches can change a little over a small amount of time, shouldn't they be able to change a lot over a long period of time? Assuming that the amount of change a given species can experience is essentially limitless, it will just take a little longer for microevolution to slowly lead to macroevolution. To scientists of Darwin's day, this sounded like a reasonable argument. You see, they didn't know what we know about genetics. They didn't know that the genetic code is responsible for determining the range of characteristics that a species has. Thus, they didn't know that the natural variation we see in reproduction today is simply the result of different alleles being expressed in different individuals. Since we know that the number of alleles in the genetic code of any species is limited, we also know that the natural variation which occurs as a part of reproduction is limited as well. Thus, unlike Darwin argued, the variation that a species can experience is not unlimited. It is limited by the number and type of alleles in the species' genetic code. Thus, today we know that macroevolution cannot occur the same way that microevolution occurs. You see, microevolution is simple to explain. When God created the animals and plants, He built into their genetic code a great amount of variability. As these plants and animals began reproducing, this variability began manifesting itself. This built-in variation was then acted upon by natural selection to create the variations that we see within a particular kind of creature. Thus, God probably created a typical dog during the creation week, and then the process of microevolution produced the many variations of dog that we see today. Microevolution, then, is a testament to God's foresight. As the Creator, God knew that the creatures of His world would have to adapt in order to survive. Thus, He built in their genetic codes the ability to change. And microevolution is simply the theory that describes how that change takes place and is directed by the pressures of the environment. Macroevolution, however, is something quite different. The hypothesis of macroevolution assumes that a given life form has an unlimited ability to change. This means that some process must exist to add information to the creature's genetic code. After all, a creature's ability to change is limited by the information in the genetic code. There are only a certain number of genes and alleles of those genes. There is therefore only a certain number of possible variations in genotype, and therefore a limited number of possible phenotypes. Thus, in order to get an unlimited amount of change, a creature must somehow find a way to add genes and alleles to its genetic code. This is something altogether different from microevolution. And as we will see in the next few sections, there is precious little data supporting such a hypothesis and quite a lot of data contradicting it. In the end, then, we can distinguish between microevolution and macroevolution by referring to genetics. If we're talking about a species varying within its genetic code, we are talking about Microevolution. This is how wild dogs became domestic dogs and how the many varieties of finch formed in the Galapagos archipelago. On the other hand, if we are talking about a species suddenly adding information to its genetic code, we're talking about macroevolution. The distinction is quite important because the former is a well-established scientific theory, while the latter is an unconfirmed hypothesis. Well, friends, that ends part 3. Thanks for listening again. See you soon, or you'll hear me soon. Bye now.